Hello, I'm here to help you utilize the dot and cross product identities to solve the given problem. The given problem reads, if vector A dot vector B is equivalent to the square root of 3 and vector A cross vector B is equivalent to the vector 1, 2, and 2, find the angle between vector A and vector B. So I like to tackle this problem by first rewriting our givens. I find this is a great way of keeping oneself on track and focused on the problem. As we all know that calculus can get a little bit confusing if you don't keep track of everything that is happening with the problem. So here, we rewrote it. Now let us write down some dot and cross product identities that we can utilize to solve this problem. So the first problem, the first identity, rather I should say, that we should write down is the following. The magnitude of A cross B is equivalent to the magnitude of A times the magnitude of B times sine theta. Similarly, for the dot product, we can write down vector A dot vector B is equivalent to the magnitude of A times the magnitude of B times cosine theta. Okay, so now that we have these identities, we should probably seek to find the magnitude of A cross B. So we can do that easily right over here. So the magnitude of A cross B, this will become the square root of the insides squared. So we have 1 squared, which would be just 1, plus 2 squared, which would be 4, plus another 2 squared, which is again 4. This gives us the square root of 9, which we all know to be 3. So now let us substitute back in these values we have into the problem. So we have 3 is equal to magnitude of A times the magnitude of B sine theta, and square root of 3 is equal to the magnitude of A times the magnitude of B cosine theta. So now, let us divide these quantities to get theta. So we end up with 3 divided by the square root of 3 equivalent to, so we know that the magnitude of A times the magnitude of B divided by itself would be just 1. So we can write 1 times. And we know that sine divided by cosine is tangent. So we can write tangent theta. And now we can seek to solve for theta. So to solve for theta, we will do the inverse tangent. And we will isolate theta, and by doing so, we will allow ourselves to find the angle. So here you should probably pull out your calculators, and once you do, you'll find out that this is equivalent to 60, which is equivalent to theta, which means that 60 degrees is your theta in this problem. And this is how we can utilize the dot and cross product identities to solve for this problem. Thank you.